and welcome to Preston College's flipped lesson. My name's Peter Deeney and this is the first GCSE Maths Foundation course flipped lesson. What is a flipped lesson? A flipped lesson is where you as a student go away and learn about a topic and then bring that knowledge and understanding to the lesson, where we cover it again very quickly and do some practical exercise using your new skills. Last week we did graphs and coordinates, and today's flipped lesson topics are going to be gradients and y-axis intercepts. Enough of me and back to the screen. Last week in the classroom we covered graphs and coordinates, where we looked at basic plotting and reading of coordinates. We did something slightly trickier in calculating the midpoint of two coordinates. We looked at fixed values of x and y. For example, where x equals 2, it draws a vertical line through the x value of 2. And finally, we finished off looking at real life graphs. For example, speed, distance, time graphs. And as always, you got your homework. Well, one of your questions in your homework is to do with that missing topic, gradients and y-intercepts. And that is what we're going to cover today. As I cover the topic, if you follow my cursor, it should appear to you as a yellow circle. As we go through the slides, this is what I'll use to highlight what I'm talking about. Okay, this lesson comes with a C-zone warning. That is, that most of the topics that we're about to cover appear at the C grade standard, so they're all quite tricky in their own right. These are the trickier questions, but you have to know these subjects just in case they come up in the exam. You can't afford not to answer a question. Okay, so what are we doing today? The idea is that any straight line on a graph can be described using only two bits of information. The first thing is the slope of the line, how steep it is, and that's in mathematics is what we call the gradient. And the other thing we need is where does this line cut the y-axis, known as the y-intercept. So where does the line cut the y-axis? And with those two bits of information, we can describe any straight line that we're given, whether they give us a graph of the line or whether they give us an equation for a line like you practiced in the classroom. Just to show you what I mean, when we talk about gradient, we're talking about how steep our line is. So the gradient can be very steep, so that's a large number, to very small, which means this is a fraction of a number. And we'll look at those specific values in a minute. Then when we talk about the y-intercept, once we've got our gradient set, the question is where does it cut our y-axis? So how far up or down should we place our line? And with those two pieces of information, we can describe any straight line that we're given. Okay, let's look at the gradients. How steep is our line? First of all, before we go on how to calculate the gradients, we need to know that gradients can be positive or negative. And this is quite straightforward. So once you get this straight in your head, you'll never get the sign wrong for a gradient. If our line is to the right of 12 o'clock, round to 3 o'clock, it is a positive gradient. So anywhere between 12 o'clock and 3 o'clock is a positive gradient. If, however, it's between 12 o'clock and 9 o'clock, so to the left of 12 o'clock, round to 9 o'clock, it is negative. If we go past 9 o'clock like that, it becomes positive again. If we go round to the left, so it's between 12 and 9, negative, and again through 9 o'clock, it becomes positive round to 12 o'clock. So positive and negative. And the diagram on the right represents this. So anything to the right of 12 o'clock positive and anything to the left negative. Okay, so how do we find a gradient? Well, it depends what we've been given. If we've been given a graph, then we need to use a basic calculation, which we'll go on to in a second. If we've been given an equation, for example, y equals 2x plus 3, then it's very easy to work out the gradient for that information if you know what you're looking for. And again, I'll show you how to do that. Okay, let's start with gradient from a graph. So we've been given a line on a graph. The equation in mathematics to work out the gradient from a graph is you need to work out the difference in y values between 2 points. So select 2 points here and here, and you work out the difference in the y value. You can either count it or you can take it or work it out from the coordinates, which is what we'll do in a second. But if we were counting it, it's 1, 2, 3, 4, 5, 6. So our difference in our y coordinates is 6. And this is sometimes known as the rise. So the up and down distance is the rise. The left and right distance, the difference in our x values, is 1, 2, 3. So our difference in x, dx, is 3. So 6 divided by 3 would give this line a gradient of 2. Our rise, 6, divided by our run, you run along things, so that's 3. 6 divided by 3 gives us the gradient 2. I don't mind which of these two you use. Rise divided by run is a good way of remembering it. dy divided by dx is something we use in mathematics quite a lot, and if you go on to do further mathematics, you'll see that written in quite a few places. Okay, let's try and work a few out. In the classroom, the first question on your worksheet when you were plotting graphs was y equals 3x. And when you drew it, it would have drawn this green line here. And what you did in class is you substituted values for x of 1, 2 and 3, and that gave you your values of y, 3, 6 and then 9. So to work out the gradient of that line, if we were given just the green line and not the equation, you would pick 2 points on the line and you would say, what is my rise divided by my run? So my rise is 1, 2, 3 and my run is 1. So 3 divided by 1 gives me a gradient of 3. Now note very carefully, it's a positive 3. It's to the right of 12 o'clock. What happens if we're only given the coordinates and we don't actually see the line? Well, again, if you know the two coordinates on your line, so A is 2, 6 and B is 1, 3, it's no different. You work out the difference between your two y values. So my first y value is 6 and my second is 3. So 6 minus 3, the difference in my y values is 3. The difference in my x values are 2 subtract 1, so 2 take away 1 is 1. So my gradient using our maths term dy dx, my difference in my y divided by my difference in my x, is 3 divided by 1, which again gives me 3. Okay, let's look at gradients from equations. This is really quite straightforward. Essentially, the number that is multiplying the x term is the gradient. So on the most simple line we have, y equals x, there's an invisible 1 next to the x. Remember when we were doing basic algebra, we just don't write the 1 down. So the gradient of y equals x is 1. If we plotted that line where y is 1 and x is 1 and y and 2 is x is 2, it would draw this green line. This line, y equals x, is a very good line to remember because it has a gradient of 1. Anything above it will have a gradient bigger than 1, so 2, 3 and 4 and so on will be steeper, and it allows you to imagine that. And anything less than 1 will have a fraction of a value, a half, a quarter, a third, will be to the right of that gradient 1. Let's have a look at a couple to show you. So y equals 3x. This is our x term. The number multiplying x is 3. 3x from algebra means 3 times x. So our gradient for this line is 3. So if x had a value of 1, y would have a value of 3. And if we plotted this line, it would look like this. So the red line equates to the red equation. So every run of 1, I have a rise of 3. Every one of 1, I have a rise of 3. And that's my gradient of 3. So you can see it's steeper than our gradient of 1. Now let's have a look at a smaller gradient. Y equals x divided by 2. Well, from algebra you know that x divided by 2, and what we did in basic fractions, anything over 2 is something to do with a half. So x is being multiplied by a half. So our gradient in this case is a half. So we're expecting it to be less than this line here. So if x had a value of 1, y would have a value of a half. If we plot that line, what it means is for every rise of 1, we have a run of 2. For every rise of 1, we have a run of 2. And that's how we get this line here. The purple line equates to the purple equation. So the purple line gives us a gradient of a half, which is what we expect, less than 1. Finally, gradients from equations can be negative. For example, minus 2x means minus 2 times x. So when x has a value of 1, y has a value of minus 2. If we plot 3 points, like you were shown in the classroom, the line would look something like that. We know it's negative because it's left of 12 o'clock, and with a gradient of 2, it means it has a rise of 2 for every run of 1. That's what the gradient is, the rise divided by the run. So for every 2 it goes up, it goes a run of 1 across 1. dx 1, dy 2. So dy divided by dx, 2 divided by 1. Okay, a quick recap on gradients. Finding gradients. You'll be given one of 2 tasks. Find the gradient of a graph. You now know that you have to use some kind of calculation. If you're talking in maths terms, we talk about the difference in 2 y values divided by the difference in 2 x values. So you pick 2 points and you work out the difference in the y divided by the difference in the x. If you don't want to use the maths term, then a very good way of remembering it is the rise, so it rises 1, divided by the run along 3. So you run along 3 and you divide it into the rise of 1. So the gradient of that line is 1/3. If you have to find the gradient from an equation, it's really quite simple. Y equals 2x plus 3. You now know whatever is multiplying our x term is our gradient. So in this case, 2 is our gradient. If x was divided by a number, then it would be a smaller gradient, a fraction of a gradient. And if x is on its own, we found out that x has a value of 1. So the gradient is 1. And you should now have an idea of what a gradient of 1 looks like. And don't forget negative in gradients as well. So anything to the left of 12 o'clock is going to be negative. Okay, to check your understanding when I see you next, we'll have a quick exercise and do some challenging questions on gradients. This will also go for y-axis intercepts, which we're going to cover next. So the y-intercept, how do we find the y-intercept? Well, it's exactly the same conditions as before. You're either going to be given a graph where you have to read where the line cuts the y-axis, or you're going to be given an equation where the information is actually contained somewhere in our equation. And we'll have a look at those two now. The beauty of the y-intercept is there are no calculations required. They're really quite obvious. And I'll show you how. Let's have a look at a y-intercept when we're given a graph. So we've been given this graph here, and here's our line. It's really quite obvious to see that our y-intercept goes through +3, and the sign is quite important. That's a +3. If our line went through here, our y-intercept would be -2. So it's placing our line. We've already sorted our gradient. Where does our line live up and down the y-axis? And that is what we call the y-intercept. So here, my y-intercept is -1. And the sign is important because it relates to our equation. When we look at a y-intercept from an equation, so we've been given the equation y equals x plus 2, so you know it has a gradient of 1. It's the +2 that tells us where the y-intercept is. Okay, so when you read the y-intercept off here, it's +2. You know that your equation is going to look like something to do with x plus 2. So it's the +2, in other words, the term that you add to the x term, that is your y-intercept. Let's look at some very quick examples. So if we had a line y equals 2x minus 3, I'm not particularly worried about the gradient at the moment. If we just place this line and assume it's got a gradient of 2, it would go through the y-axis at -3. If we look at the next line, y equals -4 plus 2, if I quickly make this a negative gradient and let's pretend it falls quite steep, that would cut the y-axis at +2, and it would look something like that. Finally, y equals x over 2, so we know our gradient's a half. I'll quickly do it really roughly, that's about a half. We know it goes through the y-axis at +3/4, so we place our line at +3/4 roughly there. So you can see the y-intercept from an equation, when it's in the format y equals something to do with x plus or minus a number, whatever the plus or minus the number is where it cuts the y-intercept. If there's no number there at all, let's say for example we had y equals 2x and there was nothing there, what that means is it goes through the origin. It goes through 0, because you don't add or subtract 0. We don't show that. So it would be y equals 2x, and that would be it. You don't write anything to do with the 0, and we'll look at that again in a minute. Okay, so let's have a very quick recap on y-intercepts. Okay, when you're given a graph of a line, the y-intercept is where it cuts our y-axis, for example 1 on this particular diagram. When you're given an equation, the information for the y-intercept is really obvious. It's whatever we add or subtract to our xth term. So in this case, our y-intercept will be at +2. Okay, now let's look at graphs and equations. You've already got the skills to plot 3 points and draw a line graph. So if I gave you an equation along the lines of y equals 3x plus 1, you would substitute a value of 1 for x, and that would tell you that when x is 1, so if we just quickly write that in there, so when x has a value of 1, y has a value of 4. And when x has a value of 2, we substitute it in our equation. 3 times 2 is 6, plus the 1 gives us 7. And finally, if I put a value of 3 in there, 3 times 3 is 9, plus the 1 would give us 10. So a value of 3 would give us 10. And that is how you would have drawn your graph from an equation. Well, there's actually another way that we can do this, and that is using something called the gradient intercept method, because everything we need for our straight line is contained in the equation. We know the gradient is 3, we know it cuts the y-axis at +1, so we can draw our line using a method called the gradient y-intercept method. So let's have a look at an example then. Y equals 3x plus 1. Well, the first thing to do really is to actually sort of put a little mark on your graph at where it cuts the x-axis. So let's just get a pen here. Let's put a little dot, and we know that our line is going to go through there. The next thing I need to do is actually draw a line, so let's get a line that has a gradient of 3. So a gradient of 3 is rise divided by run. So if I start my line on 0, I know it's going to go up 3 for every 1 across. Now, let me just extend the line. So if I go up another 3 and across 1, down 3, so 2 goes to 6. So that's my gradient of my line. And what I'm going to do, just for you, is I'm now going to move it. So that's a gradient of 3. So 3x means a rise of 3 divided by a run of 1. A rise of 3 divided by a run of 1. Okay, but this line really needs to be placed through plus 1. So the line y equals 3x plus 1 will look like this. This format of the equation, y equals the x term plus or minus something, in maths is known as y equals mx plus c. Those of you who've done maths in the past will probably have seen something like this and wondered at the time what it was about. All it is if you go back to our 4th lesson on algebra, we talked about not knowing what values were and sticking letters in. So in this case up here, we know we've got a gradient of 3 and a y-intercept of 1. When we don't know what those values are for a line, so we're given a random line, we can say y is equal to something times x, and we just use the letter m, plus c. And c is what we call a constant. Where does it cut my y-intercept? So this is just algebra's way of saying I've got a straight line, but I really don't know what my gradient is or where it cuts my y-axis yet, and I'll fill them in a minute. Let's have a look at that. Okay, let's look at the gradient y-intercept method again for 2 more lines. Y equals x minus 3. So the first top tip is put a little dot where it cuts our y-axis. Now notice it's minus 3 this time. So whenever we've drawn our line, it's got to go through minus 3. Now let's draw our line with the correct gradient. We know the line has to have a gradient of 1 because there's an invisible 1 before the x. So we're now going to draw a line with a gradient of positive 1. So all that means is for every 1 I go along, I go 1 up. So that's actually quite a nice diagonal line. Okay, so that's our gradient of 1. However, it's in the wrong place. It really needs to go through, let me just, minus 3 to actually suit our equation. So here I've got a line of gradient of 1 and it's gone through that point, minus 3. Let's look at the next one then. Same again. What we're going to do is we're going to mark our y-axis where our line cuts through, and we know it cuts through, if I can just grab a dot, plus 2. So I've got a little red dot on plus 2. So that's going to remind me, once I've drawn my gradient of minus 2, that it's got to cut through the y-axis at plus 2. So now let's look at a gradient of minus 2. Let's draw a line again. Okay. So what does a gradient of minus 2 mean? Well, it means that for every 2 I go up, I go 1 across, but it's negative, left of centre. For every 2 I go up, I go 1 across again. So this is my gradient of 2. For every 2 I go down, I go 1 across. For every 2 I go down, I go 1 across. So that's my line. Okay, 2 down, 1 across, 2 down, 1 across. So this is my line for y equals minus 2. So I've got a gradient of 2, a rise of 2 for a run of 1. It's negative, so it's left of the x-axis. And finally, I know it cuts my axis at plus 2. And if you notice, both of these equations are in the format y equals mx plus c again. I've got something multiplying x, and I've got something adding or subtracting from x, telling me my y-intercept. Finally, What we're going to look at with respect to gradients is this equation y equals mx plus c, where m is the gradient and c is the intercept. And we're going to create a random line based on rolling a dice. I don't know what the answer is going to be, but we'll do it just to show you how easy it is to do plotting graphs from gradients and y-intercepts. So our gradient is going to be 3, and it's going to cut the y-axis at 4. So the first thing I really need to do is quickly draw a point at +4. So this is where my line is going to cut through. Then I need to draw a line through that point that has a gradient of 3. So our gradient is 3. So we know it's positive 3, so it's right at 12 o'clock, and a gradient of 3 means, oh, sorry, didn't draw the line. Just draw the line again. Gradient of 3 means for every 3 I go up, I go 1 across. A rise of 3 for a run of 1. A rise of 3 for a run of 1. Okay, we go down 3, 1, 2, 3 for a run of 1. We go down 3, 1, 2, 3 for a run of 1. So our line will look something like that, where it has a gradient of 3, which is quite steep, we know that, and it passes through our y-axis at 4. Y equals mx plus c, y equals 3x plus 4. And you can practice these yourself using a dice or making up the numbers that multiply x or add or subtract from x. Okay, so we've looked at this. Y equals mx plus c. If we're given a graph, it's easy to write our equation out in full. Okay, we now know 2 bits of information. We know what our gradient is, and we know what our y-intercept is. So, looking at the graph we've been given, if we're asked to write an equation in the format y equals mx plus c, we know that y is equal to, well, I know my plus c is my y-intercept, and it's actually not a plus c, it's a -2. Can you see that? So the line cuts through the axis, the y-axis at -2. So I can do the first bit of my equation really easily. The next thing I need to do is look at my graph and look at my run and my rise. So it's my rise divided by my run, or my difference in my my difference in my y divided by my difference in my x. So if I put a rough line down there, so my rise, we call it the rise, that's really badly written, is 3. And we divide it by the run. And the run goes from here to here. And my run is 1. So my gradient is 3. So my equation for this line is 3x minus 2. Quite straightforward. Okay, so what if we have a line that goes through 0? And we've talked about this before. Essentially, all it means is that when you're looking at your plus c is actually +0, so we don't show it. So your equation, in this case, would be y equals mx. And there's no plus c because adding 0 or subtracting 0 doesn't give us anything to that equation. Okay, so we've looked at linear graphs now, and we know that they're in the format of y equals mx plus c. When we were in the classroom, we said this quite simply, that any equation that had the value of x to the power 1 would draw a straight line. We're going a little bit beyond that now, and we're saying any equation that has x with a power of 1, we can tell that whatever multiplies x is our gradient, and anything that adds or subtracts from our x term is our y-intercept. That's sometimes known as the constant, but it's better known as the y-intercept, where it cuts my y-axis. There are tools on the internet, and I've given you links at the end of this lesson to these tools, where you can draw lines and play around with these values. So using this plotter type tool, I can change my gradient M, and I can make it bigger or smaller. So I can make it 2, I can make it 3, 4. You see how the gradient gets bigger? The line gets steeper. I make it smaller, it gets flatter. If I go to 0, it's horizontal. However, we know that the gradient of 1 is a good marker. It's a 45-degree line. If I put a half in there, you can see that it gets shallower. If I put a smaller fraction, for example 0.3, it gets shallower again. Okay, so anything below our gradient of 1 is going to be a fraction, and then above it is a larger number. And then moving the line up and down, you can play with these tools. You can see that if I make the constant, the y equals mx plus c plus 2, our line now goes through plus 2. And you can draw any line to your heart's content using these internet-based tools. Okay, let's do a quick gradient on a line from an exam question. So the exam question shows you the graph, and we now know to work out the gradient from a graph that we've been given, we need to select 2 points and work out the rise against the run. Sorry, just select a pen here. Okay, so let's have a look at this. In order to work out our gradient, we need to know our rise, which, looking at the scale, don't get drawn into these things, has a value of 10. So our rise is 10 and our run is 1. It goes from 0 to 1 on the x-axis. So our gradient is 10. However, important to remember, it's to the left of our y-axis. So it's negative 10. And that would get you 2 marks. 2 marks that before this lesson you probably wouldn't have achieved. Hopefully now it's quite straightforward for you. Okay, let's have a look at parallel lines now. Parallel lines. Basically, a parallel line is a line with the same gradient but a different constant, a different y-intercept. So if I have an equation here, y equals 3x plus 2, we know that it has a gradient of 3. If another line has a gradient of 3, we know it will be parallel to this one, and in this case this line cuts our y-axis at plus 2 and this one cuts it at minus 4. Let's have a look at that visually. Okay, so the orange line is going to represent our gradient of 3. So let's put it on here and draw a gradient of 3. So move it round, it's positive 3. So for every rise of 1, so that's roughly 3 there. So has a gradient of 3, that's my gradient of 3. However, it goes through my y-axis at plus 2. So we know it cuts the y-axis at plus 2. The other line, okay, the other equation has the same gradient. So when I set my gradient, if I can do that, we know that we have a rise of 3 for every run of 1. That's what a gradient of 3 is. So it should look something like that. However, this line has a y-intercept at minus 4. So I need to move my line down a bit. And it cuts through minus 4. So these are parallel lines because the gradients are the same. Where they cut the y-axis is the distance between the two lines. That's what sets the distance between them. And finally, the last little bit. Now we're experts at linear equations and understanding gradients and y-intercepts. We're going to have a look at a practical example that will help you with your homework, which is question 4 in your homework. If I just show you quickly what I'm on about, question 4 in your homework is to do with hiring a mountain bike. And if you look at these equations at the bottom, you've got to define this line based on the format of y equals mx plus c. Okay, so let's have a look at something very, very similar, real life graphs. I want to join my local gym, and there are two membership plans. Okay, the first plan, Plan A, charges £3 a day when I go, but I only need to pay a deposit of £5 up front. So next week we're going to talk about formula from sentences like this. So I'm going to do this one for you. The cost of me going to the gym is going to be £3 times the number of days that I go plus my £5 deposit. And in maths this will look like this. My cost equals 3D, 3 times the number of days, plus 5. Don't worry too much about this. We'll go on to formula later. What I need you to know is that C equals 3D plus 5. Plan B for me going to the gym is to only pay £2 a day, but there's a bigger upfront cost of £10. Again, our cost for going to the gym is 2D, £2 times how many days I go, plus that £10 deposit up front. So my second plan is C equals 2D plus 10. Let's have a look at what they look like as graphs. We now know what the graphs look like. Okay, so rather than having y equals mx plus c, we've got c instead of y and d instead of x. Don't forget algebra, we can swap these around to our heart's content. So the line c equals 3d plus 5 would look like the orange line here. So when I have a value of 1 in here, so on day 1, I've paid my fiver, but I also need to pay another £3, it's £8. So we know the gradient is 3, and we know the y-intercept is 5. So the y-intercept is 5, and I have a gradient of 3. Now don't be put off by the scales. For a run of 1, I have a rise of 3 between 5 and 8. Yeah? For a run of 1, I have another run of 3. Okay? It's just the scales that might be throwing you. So be aware of the scales on graphs. Plan B was C equals 2D plus 10. So we know the plus 10 is where it hits our y-axis. So even before I've gone to the gym, I've paid £10 up front. I have a gradient of 2 for this line. So for every run of 1, I have a rise of 2. Again, don't let the scale fool you. I have a run of 1, and that goes up to 12. Okay, I have a run of 1, it goes up to 14. So don't let that scale fool you. And that's what the two graphs look like. So what does the graph tell us in our real life situation? Well, it tells us that plan A is actually cheaper up to 5 days. On the 5th day, they're the same price. So if I went to the gym 5 days, there's no difference between the plans. If I'm going to go to the gym 4 times or less, I'm better off going for plan A. If I go to the gym more than 5 times, then I'm better off going with plan B, because plan B is cheaper on cost. Okay? And this is very similar to the one you've got in your homework and some other exam questions we've seen over the years. Okay, to finally recap, we now know how to calculate gradients. If we're given a graph, we know the gradient is our difference in our y divided by our difference in our x. Our rise of 2 divided by our run of 1. 2 divided by 1 gives me a gradient of 2 for this line. If we need to find the gradient from an equation, we just go to our x term and find out what is multiplying our x term to work out our gradient. So in this case, y equals 2x plus 1, we now know that 2 is our gradient. The y-intercept. The y-intercept is really quite straightforward. If you're given a graph, you can visually see where it cuts your y-axis. Here it is plus 1, and the plus 1 is very important because that's what you add to your x term, plus 1. If you need to find your y-intercept from the equation, it's the term added or subtracted to your x term. So in this case, it's +1. In mathematics, before we've calculated our gradient and our y-intercept, we use the algebra phrase y equals mx plus c. And this is a formula because we don't know either of the values for m or c at this point. And finally, don't forget that it doesn't always have to be y's and x's. As you saw in our real life situation, the y can become cost and the x can become the number of days. So the graph can be cost against the number of days. Not all graphs are y against x. However, if they're in this format and they're in a straight line, nothing changes. Whatever is multiplying this term is your gradient. Whatever is added or subtracted from this term is your y-intercept. And finally, parallel lines. Parallel lines have the same gradient. So 2x has the same as 2x up here. However, they need to have different y-intercepts. So here our y-intercept will go through -3. Here it goes through +1. So a parallel line has the same gradient with a different y-intercept. And that's it. That's the flipped lesson. We'll check your understanding when we get into the classroom on gradients and y-intercepts, and also y equals mx plus c, and parallel lines and real life applications using those skills. Much of what we've covered can be seen on the internet. If you want to play around with a graph plotter where you can play around with gradients and y-intercepts, fooplot.com is one of the better ones. Then there's also one at Maths is Fun. If you want to draw or work out equations from a graph, there's a YouTube link to somebody explaining in a slightly different way how to get an equation from a graph. If you want to draw a graph using the gradient intercept method, then there's another YouTube feature video showing this. Don't forget, you also have numerous resources that I've already given you. We have the CGP books and videos that you can look at, and if the worst comes to the worst and you still don't understand it after this presentation, you can always ask me. We'll check your understanding next week when I see you, so good luck and I hope you've enjoyed this video. Thank you.